Have you ever wondered how we can write code that works with multiple data types without rewriting it over and over again? Imagine needing a stack that stores integers, one auto stores floating points and another for strings. Instead of writing separate implementations, we can use a powerful feature of C++ called templates. Hey guys, welcome back to the Tech Tutor. In today's video, we're diving into templates in C++, one of the most essential tools for building efficient and reusable data structures. Whether you're working with stacks, queues, linked lists, or trees, templates make it possible to write one implementation that works for all data types. Let's jump right in. So what are templates? A template in C++ is a blueprint that allows us to write generic code that works with any data type without rewriting it multiple times. Instead of creating a function for int, another for float, and another for double, we use a template function that adapts to the data type we provide. Templates are especially used in data structures, allowing us to implement stacks, linked lists, and trees that work with any data type. So why use templates? Again, here are three key reasons. Code reusability, write once, use for any data type. Flexibility, use the same logic for different data types. Type safety, avoid type mismatches while keeping compile time checking. So by using templates, we can reduce redundancy and write clean, scalable, and efficient code. Let's start with function templates. Instead of writing separate functions for different data types, we create a separate function. So we create a single function that works for all types using a template. So here's an example of a function that adds two numbers of any data type. If you look at the parameters here, we're taking in something that we haven't come across. We're saying T, A, T, B. Okay. Now if we look at the usage over here, you would see I'm calling add and I'm adding it with integers, but I'm also calling add and I'm calling it with doubles over here. So as you can see, it works seamlessly for integers, floats, and it's even gonna work for doubles. Okay, so we don't need separate functions. The compiler generates the correct function based on the type. Okay, so as you can see, this is a benefit of templates. Now coming to another type of templates, which we call class templates. Just like function templates, class templates allow us to create generic classes that can work with multiple data types. Here's an example of a generic class that holds a single value. Okay, so if you look at the syntax over here, template type name T. Also, I would recommend also working the code out to see how this actually works alongside me. Okay, so here's an example of a generic class that holds a single value. Okay, so what we do again here, we're creating box objects for any type. So we're creating box objects for integers, and we're also passing in a double value. Okay, so as you can see, we are creating. It's not just functional. Now we're creating different template of a class. So I could create an object of an integer. I can create an object of a double. So this is extremely useful when designing data structures that handle multiple types. The templates with multiple parameters. What if we want to create a class or function that works with two different types? We can use multiple type parameters in templates. Here's an example of pair class that stores two different types. Okay, so here it's storing two different types, T1F and T2S. Okay, two different types. So over here, we can create pairs with different data types. You can see the 5 integer is the integer and 3.14 is the double that we have, and both of them are different. Okay, so you can see we're not just having the same data type, now we're actually mixing it up. So it is incredibly useful for storing key value pairs or any mixed data type structure. Okay, now template specialization. Sometimes you want a specialized version of a template for a specific data type. This is called template specialization. For example, let's say we want a custom message for bool values in our box class, okay, in our box class, and we want it to give a custom message, okay. Now when we create a box bool over here, it prints a special, and we say b.show, it prints a special message, okay, instead of showing us a value, okay. So this is extremely useful when a generic implementation needs some kind of custom behavior for certain types, okay. So again, we're kind of adding that custom specialization. If you also see, we're adding that over here, over the mentioned bool, right? Now, templates and data structures. Okay, templates are actually very widely used in data structures like stacks, queues, linked lists, and trees. Here's a simple example of a generic stack implemented using a template. Okay, so as you can see, the basic stack functions, which we will come across in future videos, push, pop. So what this does is this allows us to create stacks of any type. Okay, and just to look at just to see, if we wanted to initialize this, we could create a stack of integers. We could create a stack of strings. So this makes data structures more reusable and efficient. Now, coming to some common errors and best practices, here are some common mistakes that people make when using templates. So forgetting template, the type name t before defining a function or class, using t without defining it, trying to use a template for a type that doesn't support required operations. Okay, now coming to some best practices is using meaningful type names like t, u, type for clarity. Prefer pass by reference for efficiency in large objects. Okay, and use template specialization for better optimization. That's it for this video. Let's quickly summarize. Templates allow reusable and flexible code for multiple data types. Function templates let us write type-independent functions. Class templates help us build generic data structures like stacks and linked lists. Specialization allows customization for certain types. Okay? Alright. Thank you for watching. If you found this video on templates useful, give it a thumbs up, like, share, and subscribe for more tech tutorials. And drop a comment in the comment section below if you have any questions or any recommendations. And see you in the next one. Thank you.